Hello Bobcats. So today we're going to talk about resonance structures. So let's take a look at carbonate ion, CO3 2-. And as I go through and make this structure, we have, when I count my valence electrons, we have 1 carbon with 4 valence electrons plus 3 oxygens, so that's 3 times 6 valence electrons for each oxygen, plus we have an extra 2 electrons because of this 2- right here. So we have 2 electrons. So when I add them all up, we get 3 times 6 is 18, plus 2 is 20, plus 4, that's 24 electrons. Okay, so carbon will go in the center. And then we have 3 oxygens, so I'm going to make my skeletal structure with the 3 oxygens. Then I'm going to place electrons until I get to 24 electrons on the outer elements. And so we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Again, I notice that I do not have my carbon with a filled octet, so I take from the rich and share with the poor. So I'm going to take this top 2 electrons and I'm just going to kind of get rid of them and put them right there. So now we have a structure for carbonate, and I'm going to make sure I have everything correct. So if I look, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons, and everything has an octet. And if I look at this, this has a bond order that is equal to, well, you've got 1, 2, 3, 4 bonds divided by 1, 2, 3 bond domains. So that has a bond order 1.33. So what we're saying here, and because these electrons could have been shared from this oxygen or from this oxygen, this could have a double bond, single single, or double single single. The molecule doesn't see it as 2 singles and a double. It really is looking at bond orders of 1.33. So I have to be able to show how these electrons are shared equally between all of these bonds. So to do that, we create resonance structures. So resonance is a condition that occurs when more than one valid Lewis structure is a condition that occurs when more than one valid Lewis structure can be written for a molecule. And the structures must be equal to each other, okay? So if I look at my carbonate, I have my first structure up here, so we have carbon. I'm going to kind of put it at a triangle now, just so there's my first structure. Now, I could have taken the electrons and shared them from this oxygen. In fact, that's what I'm going to do for my next structure, is that these lone pair, we're going to go down to make a double bond, but that means these have to go back up to here. So we're going to have a carbon, double bond, oxygen, single bond, oxygen, single bond, oxygen. And yes, you have to draw the double-headed arrow because that means that these are equal to each other and these electrons are equally shared between these bonds, this pair of electrons. In our last structure, so we had a double bond at this oxygen, a double bond at this oxygen. Let's put the double bond at this oxygen now. So we have a carbon, single bond, double bond, single bond. 1, 2, 3, 4, 5, 6. 1, 2. And so here is the third structure that I can make from this. So these are resonance structures, and what they indicate is that these electrons are shared equally between all three of the oxygens and carbon bonds. And so it's not like we have bonds that are single, single, double. We really have bonds that are about 1 1/3 each in strength and in length. In other words, remember how we said a double bond is shorter and stronger than a single bond? But in this case, they're all the same strength and length because they are shared equally. Okay, let's do a practice on this. One more practice to make sure we understand how do we do resonance structures. So the next practice, let's do sulfur dioxide. And sulfur dioxide, in this case, I'm going to go ahead and draw the structure where I'm not going to work through the process. It is a sulfur, oxygen, double bond, oxygen. And just to make sure that this is correct, let's see, we have the sulfur has 6 electrons and each oxygen has 6 valence electrons, so that's 18 total. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons, and I got 2, 4, 6, 8 for this oxygen, 2, 4, 6, 8 for the sulfur, and 2, 4, 6, 8 for this oxygen. But because the oxygens are equal, I could have put the double bond here and the single bond here, and so I would have a resonance structure where I have an oxygen, single bond, sulfur, double bond, oxygen. And that would be my 2 resonance structures for sulfur dioxide. And they were able to determine that this is correctly happening because they can use isotopes. Remember, we have maybe an oxygen 16 isotope here and an oxygen 18 isotope here. And you can identify that both have equal bonds, which would be 1 1/2 between these two, or there's an equal share of those electrons between these 2 bonds. So that's a resonance structure. We'll do one more. Well, that's good enough for resonance structures. And you'll have to practice them on your own. But remember, if I have a double bond and lone pairs that can switch places between elements that are equal to each other, then you'll get resonance structures. And that's that for that lecture today. Thank you.